Welcome to Painting Outside the Lines, everyone. I'm Melissa Erickson. I work at Tableau. I'm a software engineer on the visualization team.
And I'm Kenneth. I'm an engineering manager at Tableau, and I also work on the visualization team.
So we're just going to start off with a few things about us. Kenneth here has been at Tableau for 4 years. He came most recently from Microsoft. Oh, we're going to save questions till the end? All right, so let me tell you about Kenneth here. What did I say? That you came from Microsoft most recently, right?
Yes, that's right.
But he has a background in science, so he's always been interested in using data. That makes him a perfect fit for Tableau. On a personal note, he really likes hanging out with his kids. He really likes riding his many bicycles. And he also enjoys brewing beer, so much, in fact, that he recently founded his own brewery, which opens spring of next year.
Oh, I'll talk here. Okay. Melissa has been at Tableau 7 years. She has a background in computer graphics, so she's really interested in pixels and all things visual. Away from work, she likes to go hiking. She likes to make things, and in particular, she likes to sew.
Yes, and you can see some examples of that here. There's a couple of my nieces modeling dresses. I made them, and me wearing a costume that I made for myself. And there's also a picture of a pattern by my favorite designer, Issey Miyake, who designs garments which are not just aesthetically pleasing, but topologically innovative. Now, patterns are great because they allow me to do things more quickly and with more complexity than I might otherwise be capable of. But sometimes I design and create garments without a pattern. Understanding the underlying tools and techniques gives me the flexibility to forego a pattern when it doesn't suit my needs. We'd like to help you gain that same flexibility in your use of Tableau.
In Tableau, ShowMe is a very powerful set of templates for your data, and it quickly gets new users making interesting vizzes and discovering insights. On the other hand, experienced users tend to use ShowMe less. Knowing how a visualization is built from the ground up leads to a better understanding of how data visualization actually works. And that opens up a world of vizzes that ShowMe doesn't provide for you.
So ShowMe allows you to easily choose from some predetermined chart types based on your data. But as you know, Tableau is so much more than a chart picking tool. It's an interactive data analysis tool. If you pay attention to what happens with your viz when you use ShowMe, you'll see that ShowMe will move pills around using different rows and columns and mark encodings and levels of aggregation, calculations, all based on best practices.
But all of those choices made by ShowMe can be made by you, the user. You have direct control over a variety of knobs and levers in Tableau. And these represent fundamental building blocks of data visualization. These building blocks let you fine-tune your exploration and presentation of your data. You can even bring in additional data to allow you to add structure to your viz to put your own data into. Once you know how to use these building blocks, you can build everything that's in ShowMe without ever touching ShowMe. And then with mastery of these tools, you can go beyond that and build other chart types.
We're going to show you how to build 4 vizzes which are not available in ShowMe. Now, the precise vizzes that we chose to show you today are not the important thing. We could have chosen some other set of vizzes. And we could have even chosen to show you vizzes which are available in ShowMe and build them from the ground up. Adding more visualization types to your portfolio is a great goal, but it's not our goal here. What we want to do is show you more visualization tools to add to your toolbox. So in service of that goal, we're going to be carefully showing you all the steps of creating the viz. So as we go along, this should be accessible to beginning and intermediate users.
Those of you who are more experienced users should find all this very familiar. So if at any time during the talk you feel that your time would be better spent in a different session or getting some lunch, feel free to get up. We understand.
So as I said, we're going to build 4 visualizations, and each one of those new vizzes will bring in additional Tableau capabilities.
Melissa's going to start us off building a slope graph using rows, columns, and a calculation.
And then Kenneth is going to build a waterfall chart, bringing in a table calculation and a new mark type.
After that, I'll build a tile grid map using a secondary data source as scaffolding for our data.
And finally, I'll build a network diagram, and that's going to bring in multiple marks card panels and the path drop target and dual axis.
You're going to be able to download all this content and data afterwards. We'll publish it to Tableau Public.
All right, so a slope graph is used to show the change in a quantity or rank of a collection of entities over time. This could be from one year to the next or before and after some event.
Let's take a look at what the basic building blocks are. We can see that we have time here on the x-axis, if you can see my mouse there. In Tableau, the x-axis corresponds to the column shelf. And we have some quantity or rank. In the case of this viz, it's how some taco places were ranked in user preferences. Eater preferences. In Tableau, the y-axis corresponds to the column shelf. The row shelf.
Okay, so in addition to using the rows and columns shelves, we're going to create two calculations. Those calculations will allow us to take advantage of the color encoding that we see in this example here. So let's switch over to Tableau and build the viz.
Okay, there we go. Let's switch spots.
Okay, so Kenneth and I both happen to be in the market for new cars. I have a 1990 Acura Legend, a car that I truly, truly love, but it's 28 years old, and seriously, like some of the duct tape is 15 years old in my car. So, I'm coming to terms with, I have to start looking at a possible replacement. So,
and for my family, fitting 2 adults and 3 growing kids in a Corolla is not getting any easier, so something's got to give. So you'll see some minivans in this viz too.
Okay, so in addition to test driving and scouring consumerreports.org and other research, one of the questions that you might want to consider when shopping for a new car is, are some models of car more likely to be stolen? So we have here data which tracks the theft rates for different models of automobiles. And I've already put a filter on model so that we will just be looking at a few of the models I've been considering, plus, I threw in what is that, a minivan?
Yeah, some minivans.
For Kenneth's sake. Okay, so the data spans multiple years, but I've also put a filter on year so that the data, the viz is constrained right now to the last 2 available years of data, because the slope graph looks at a before and after comparison. All right, so we're already looking at the vehicle theft rate. This is going to be fun with the microphone. And please holler again if I hold the microphone too far away and you can't hear me. All right, so we're on the vehicle theft data set. I'm going to drag year to columns, which we already mentioned corresponds to the x-axis. And then I'm going to drag thefts to rows. And then I'm going to go up here, which I often forget to do, and I'm going to go up here to the view fit affordance, and I'm going to select entire view. All right.
So we have a line.
We have a line. So you can see what's happening here is that our data is aggregated. At each mark, we're seeing the aggregation of thefts for all of those models of cars that we have in play in the viz, right? But we want to see the thefts per model. So we're going to deaggregate the data by dragging model onto the detail drop target like this. And then so we can see which models of cars these correspond to, we're going to drag model onto the label drop target. And then I'm going to go and at some point we bump down.
You want the label menu.
What's that?
Don't you want the label menu?
I do. We'll, let's see. No, we're good. We've got it on either side. But we seem to have bumped down opacity since.
Oh, yeah, it's opaque, you're right.
So, no, that's just worse. I don't know if that's something to do with the display. Sorry about that. Can people see the lines and the labels?
You know, it's actually much more visible there than it is here.
Yeah.
We're looking at something that's kind of grayed out, but it looks okay to you, I think. So.
Okay, my apologies for that. All right. Okay, so we've got our lines. Okay, so now we can see from the slope graph that some of the car models had, the slope goes up, they had an increase in the number of thefts from one year to the next. Some of them decreased, right? But we want to encode color. We want to use color to encode whether we had an increase or a decrease, so that that'll really pop out like it did in our example slide earlier. So to do that, we need to create a calculation that represents that bimodal quality of whether we had an increase or decrease, because we don't currently have that represented in our data set. And to create a calculation for whether we had an increase or decrease, we also need to first calculate the change in the number of thefts from one year to the next, right? We have the number of thefts. Say one car in 2012 had 2 vehicles stolen, and in 2013 it had 5 vehicles stolen. We have that information, but we don't yet have a representation of the change in the number of thefts, which would be a positive of 3. So the first thing we're going to do is create a calculation to figure that out. And the way I'm going to do that is I'm going to go up to the analysis menu, and from there I'm going to select Create Calculated Field. And I'm going to call this.
I'm going to hold this while she types.
Yeah, and oh, this is going to be great. I'm going to call this Change. Can you guys hear me? Okay, Change in Thefts. Okay, so what we want to do here, I'm going to take it for right now. What we want to do here is subtract the number of last year's thefts from the number of this year's thefts. That's what we're doing in plain language, right? So in Tableau, those two quantities, the thefts last year and the thefts in the most recent year and the thefts in the previous year, those comprise a list of number of thefts. So we want to look up each of the members in that list. And so we're going to use a Tableau function called lookup. And lookup, I'm going to try it for now.
Okay.
We'll see. Oops. Okay, lookup wants an expression and an offset. And the expression that it wants is an aggregation. And that's going to be thefts, because that's what we're looking at here. And now it wants an offset. The offset is how it knows which member of that list that you want, right? So if the list had 10 members, and you wanted the last member, you would type in 10. If you wanted the, 6th member, you would type in 6. But we just have 2 items, so we can take advantage of the Tableau keywords here, first and last, which mean the first member of the list and the last member of the list, respectively. So I'm going to hand that to you. And I'm going to type in last, and then I'm going to subtract, do the same thing, look up, aggregate thefts, and our offset is first. And our calculation is valid, so I'm going to go ahead and hit OK here. Okay, and so, as I mentioned, that was just the first step so that we can now create our calculation that lets us know whether we had an increase or a decrease. So before, when I created a calculation field, new calculation, I went up to the analysis menu and I selected Create Calculated Field from there. Now I'm going to do this a different way, because there's multiple ways you can get to that dialog. And I'm going to go to Change in Thefts. I'm going to select the context menu and then select Create, Calculated Field, and you can see that Tableau pre-populates with the variable that we right-clicked on. Okay, so I'm going to call this one, I'm going to hand this to you. I'm going to call it increase or decrease. And this is just going to be a simple if statement. So if our change in thefts is greater than 0, increase. Else, we had a decrease.
Whoops.
Oops. Okay, and you can see that the calculation contains errors. That's because in Tableau calculation language, when you have an if statement, it's gravitating down.
Oh, sorry.
When you have an if statement, you need to end that with end.
Uh-oh.
Whoa. Oh, yeah. Thanks, guys. And you also need to have a then in your if then. All right. So, might as well fix my capitalization error. All right. So now we have that pill, right? We did a bunch of work to create those calculations. And now we take that new pill, increase or decrease, and we just drag it to the color drop target. Ooh. And now we get a very translucent, I was going to say that our distinction really pops out now, but it pops out a little bit, right? Color really does bring out the difference between a model which has an increase in the number of thefts and one that has a decrease. This is a little bit of a strange example for a slope graph, but you can use this to see, like, if profits increased or declined year to year, or if how the rankings for a particular set of sports team changed. It's handy for a number of scenarios.
I think we can use this to see you should definitely not get a Mustang, because people are stealing them more.
That may be the case, though I do really love an overpowered car. But it's not high on my list. All right, so
what do we do here?
All right. We used a bunch of building blocks of Tableau. We used the rows and columns, and then we walked through one calculated field, which was calculating the change in the number of thefts. And we added another calculation to make it amenable to the color encoding, and that was translating the change in number to a bimodal concept of increase or decrease. So now we'll move on to our next example, which is a waterfall chart.
Okay. Thanks, Melissa. So, waterfall charts.
All right. So we're going to show you a viz now with a different data set. We're going to use all the capabilities that we used last time, but bring in 2 new ones.
Waterfall charts are good for when you want to show the cumulative effect of some quantity that can rise or fall over time, but not continuously. The data changes in discrete time units, let's say once a week or once a day. In our example here, it's once a game. These are football game scores.
The waterfall chart lets you see those changes at each step. It lets you see those changes at each step, and it lets you see the cumulative effects of each step. So you're seeing 2 things at once: the individual step and what we call the running total.
Just like in our last chart, we're going to use columns and rows to figure out what's on the x and y axis. But this time we're going to bring in the running total, which is a table calculation. It brings with it some additional capabilities. Let's switch over to our workbook. Okay. We wanted to find a data set that was more local to Las Vegas, more interesting, and so we're going to use a data set of poker winnings. We're going to pretend that we have entered a poker tournament, all of us as the same person, I guess, with a certain amount of money to start. We're going to have a data set of the amount of money that we won or lost as we progressed through the tournament. For those of you who are unfamiliar with how this works, each round of poker, like each time the cards get dealt out, is called a hand, and you'll see hand in our data set. So in this data set, we can see the net win or loss for each hand. Like every time the cards got dealt out, did I win money or did I lose money? Since the tournament progresses with each hand, we're going to put hand on the x-axis so we can read that from left to right. So let's do that. Whoops, I got to be looking at the right data set. Here we are. So hand, I'm going to drag over to columns. Okay. And now I'm going to drag winnings to the y-axis, or the rows shelf. Okay, so we have what looks like basically a bar chart. We see here in what I've called hand zero, that's just the money that we came into the tournament with. We had to pay $10,000 to sit down at the table. In the first hand, we lost what in poker terminology is called the small blind. We had to pay $1,000 just to play in the hand. But I didn't bet or lose any money or win any money beyond that. In the second hand, we lost what's called the big blind, which is twice as much. Then, proceeding from there, I just didn't participate. I didn't like the cards I was getting, right? And then we go through another round and so on. But right now, we're just seeing the result of any individual hand. And we want that data, but we also want to know how the tournament as a whole is going at any given point in time. Sorry, I covered my hand there. Won't do that. We can get that by introducing something that we haven't covered yet, which is the running total. This is a table calculation, which means that we perform a calculation at each mark that's dependent on the previous or next mark. That's what Tableau means by table calculation, whenever you hear that. In this case, we're interested in adding the results of any particular hand to the total from all the previous hands. That's a calculation technique that would be really useful in lots of contexts. Turns out it's so useful that Tableau will do it for you. So we're going to go back to the rows shelf. We're going to right-click on the pill. We're going to come down here to quick table calculation. As you can see, there's a whole bunch of quick table calculations that Tableau will just write for you. We're going to select the one called running total. We've done it. Okay, that looks a lot different. Now that we have our running total, let's take a look at what's going on behind the scenes. I'm going to double-click on the pill so that I can see what this actually is. The type's a little small, but if you see, in calculation language, this is the running sum of the sum of winnings. That's what this table calc actually looks like, but Tableau wrote it for us, so we didn't have to. So we've got a bar chart now, which shows the progress of the tournament as a whole. It shows us the cumulative, like up to hand 17, I have $23,000 in my, I'm actually not sure what that's called in poker, my bank, sitting in front of me, right? That's how many chips I have. So before I did this table calc, I had a bar chart that showed me the result of each individual hand, but not the progress of the tournament. After I do the table calc, I have a bar chart which shows me the progress of the tournament, but not the result of each individual hand, so I've got the opposite. There is a way we can get both. We need a few steps to get there, though. So first, I'm going to change the mark type, which means I'm going to come over here to the marks card. I'm going to drop down the mark type dropdown. I'm going to change this to Gantt bar. So this looks kind of the same. I can do undo, and you can see it again, in that each mark is exactly where it was before, but now it has 0 size. I am no longer encoding both the position of the mark and the size of the mark, which means that size encoding is now open for me to do something else with. So I'm going to drag winnings up to the size shelf. There we go. So now I am encoding both the result of each hand and the running total. But there's a small problem. Our viz is making it look like I started the hand with $10,000, or I started hand 0 with $10,000, and finished it another $10,000 up. We know that's not what happened. We want each mark to begin where the previous mark ended. And there's a little trick that you can do in Tableau to make this happen. So again, I'm going to double-click on the pill to get to the calculation. I'm just going to add a minus sign. And now, what I have is that I started with 0, I ended hand 0 with $10,000. I started hand 1 with $10,000, I ended it with $9,000. It's a little bit hard to tell because at a glance, you're not sure which way the mark's going. Is this an increase or is this a decrease? You can look at the previous mark to get some context of like, oh, this is aligned where the previous mark ended, it must be going down or it must be going up. But instead, let's use color encoding, which we haven't used yet, kind of the same way we did with the last one, with the last viz, the slope graph. And we'll use a simple calc to translate a positive, negative into color. Melissa, do you remember how we wrote that?
Okay, so
So I
You
went
want to go into winnings,
yeah,
yeah, and create calculated field.
okay. So I'm not calling this won or lost because, as you can see from practicing this, I've already used it many times. So I'm going to call this did I win or lose, okay? And then the same way you did that before, we did if winnings greater than
And you're
0.
going to want an aggregation there.
Oh, you're right, you're right. I want an aggregation there. Oops. Then 1.
Oh, nice move with the then.
Yes, yes. I learned from your mistake. Else, lost, end. And the calculation's valid. Great. So now I'm going to drag did I win or lose up to color. And now I can tell, hey, if the mark is orange, that means I did well that hand. I gained money. If the mark is blue, that means I lost money. So what have we done here? What visualization building blocks have we used? And what new ones have we learned about? We started out with rows and columns again. We said to ourselves, I want to see progress through the tournament along the x-axis, looking from left to right. So since it's x-axis, I want to use that hand measure, or sorry, that hand dimension on the column shelf. Then I want to know something about what I won or lost. I want that on the y-axis. So I use that on the row shelf. Then I used a new mark type. Sorry, I used a new calculation type, which Tableau provides me, to allow me to look at the running total. Then I used a new mark type to allow me to encode 2 things at once. I'm encoding the running total with the position of the mark, and I'm encoding the size of the effect of each hand with the size of the mark. And then I used the calculation, translating things to a bimodal thing that Melissa showed us last time, to actually add some context to what's happening at each stage. Go ahead.
All right, so we're going to put another tool in our data visualization toolbox now. We're going to make use of an outside data source. The extra data source is not in itself analytically interesting, but it allows us to construct a scaffold into which we can put our interesting data.
So I'm going to switch to this. We have a data set from the Bureau of Labor Statistics, the unemployment rate in the United States, state by state. A viz type that makes a lot of sense for geographically categorized data is a map. Often when we build a map, we build a filled map with a color scale indicating some value associated with the area on the map. We've done that here for the data for unemployment rate, as you can see. I can see that the unemployment rate in 2017 for Washington is 4.5, but in, say, Colorado, it's 2.4. There's a lot of regional variation here, and if I'm a job seeker, assuming I have the resources to move, something like this might tell me where I could go find a better job.
Right. So this kind of map here can fool us. We're intentionally encoding for color, but on this map, we're unintentionally encoding for size. Because, for example, California and Texas are really big, Rhode Island is really small. If I want to know the unemployment rate in each state, I don't necessarily want the color value association that California takes on to dominate my visual. We need a way to remove size from the visual. We want the mark to only encode the measure we want to analyze.
Now I can do that with a bar chart or something. Let's just turn this into a bar chart. Here, I'm going to actually use ShowMe. Okay. So now each mark is actually encoding properly for size. I've lost my color encoding. I could add that back if I wanted to manually. But what I've lost here is I've lost my intuitive sense of where these marks should be found, right? Like, because I'm basically familiar with the map of the United States, I know where to look for Vermont. Now, I can do that here because I know that this list is alphabetized, and I can scroll down to the V's, and I can see that it's right here, right? But even though I can sort things alphabetically, and I knew how to find it, it took longer than it would if I were simply looking at a map. What I want to do is, have my cake and eat it too. I want to be able to retain that geographic sense of where these marks should be, but not unintentionally encode for size. So I'm going to switch this back. So in order to solve that problem, we have another data set that we've prepared. I'll show you how we did it. We took a piece of graph paper, and we mapped the United States onto it. And we said, roughly, where should the state of, Montana be? Well, that should be at this x position and that y position. I think it's, in this case, 3, 6. We did that for every state. And we got, if I'll show you what this data source looks like, if I view the data, we got a list of states with an XY position, right? Now, this says nothing about unemployment rate or whatever it is you wanted to analyze. This just tells you where the states are. So this external data set, not analytically interesting in itself, but awfully useful if you want to build this kind of map. I'll show you how. So I'm going to take X. Where does X go? It goes on the column shelf. I'm going to take Y. It goes on the row shelf. Now, as you can see, our data is aggregated. So I actually have another trick here. I have a data set of state abbreviations. And in order to deaggregate this data, I'm going to drag state abbreviation onto label. Now it's really starting to look like the United States. I'm going to make it a little wider. And I'm going to change label. Actually, first I'm going to adjust the size so they're a little bit bigger. Every monitor is different, so I have to, whoops, too far. There we go. And now I'm going to go into label, and I'm going to, whoops, I'm going to eventually, trackpads are hard. Okay, what is going on? I'm going to use the mouse. And I'm going to, I don't know why that's happening. I'm going to entertain you further with, I'm not going to do that, is what I'm going to do. Okay. I don't know what's going on.
But they can see it in the finished viz, which will be uploaded to public.
Yeah, exactly. Okay. Anyway, I've lost my train of thought. The reason we practice this is that everything that can go wrong will go wrong, and you can fix it ahead of time, but that's the first time for that one.
Hey, do you want to do some more formatting? Like
Let's do a little bit more.
axis?
Yeah. As long as I'm here, notice that I've still got X and Y here. Now, X and Y were important for each state, so I'd know where to put the state, but they don't really mean anything otherwise, right? Like, there's nothing analytically interesting about saying that Montana is 3, 6. So I'm going to right-click on each axis, and I'm going to unclick Show Header so that I don't confuse my user, because they look at this and they think, oh, that's the United States. I know what that is, right? So now I've got a framework prepared. Now I can actually do some analysis. So I'm going to switch over to this data set. This is the exact same data set I used for the filled map. I notice that I have blended on state, and I just drag rate here into label. And if the labels were in the middle of the mark, it would be really impressive. As it is, it's just moderately impressive that I have the label and the unemployment rate and the, what do you call those, postal codes? The two-letter abbreviation for each state. And I can also, if I want to, I could drag this to color and take advantage of my color encoding as well. So now I have preserved my user's geographic sense, right? They know where Texas is. Oh, Texas is here at the bottom. It's the nub that sticks down, right? And if they want to know what Texas' unemployment rate is, they know how to find it quickly without scrolling through a list. Same with Washington. A lot of people don't know where Washington is, but I know where Washington is because I live there. But I can just click right there. But I don't dominate my visual with the fact that Texas is such a large state, or that Rhode Island is such a small state, right? The unemployment rate in a state doesn't actually have anything to do with how big the state is, so we shouldn't accidentally imply that it does.
And now that we have the scaffolding set up, we can use it with any data set which happens to have state as a domain.
Right. You just have this states as XY grid data set in there, you blend on state, and you can use this with any data set you want.
All right, so we have one more viz to show you, and that's the network diagram. Okay, so which new visualization tools are we going to bring in this time?
Let's switch around so you can run it.
Sure. Okay, we're going to discuss how to explicitly tell Tableau how to draw a path. We're also going to show you how to take advantage of multiple panels in the marks card in order to work with distinct levels of detail. And to wrap it up, we'll show you how to use the dual axis feature. Understanding these concepts is valuable even if you never build a network diagram. Now, building a network diagram in Tableau definitely counts as an advanced visualization type. In the interest of time, we need to gloss over the most time-consuming part of this, which is preparing the data set so that it contains explicit path information. Tableau does not provide network diagrams out of the box, but we can create them with properly prepped data. At the bottom of this slide, at the end, when we upload our materials to public, there'll be a link to a blog post which details how to do this properly in detail.
How to do the data prep, right?
How to do all of it.
Okay. We use network diagrams when we want to display connections between items. The type of connection can be something concrete, like all the roads in a country, but it can also be something more abstract, like all the relationships within a social group. A network diagram allows us to see each relationship in the context of the other relationships. So
in the world of social networks, there's a famous social network data set called the Zachary's Karate Club data set. It's named after the researcher who gathered the data and analyzed it. Just a little bit sort of cribbed from Wikipedia. Wayne Zachary studied a karate club for 3 years in the early 1970s, documenting 78 pairwise connections among 34 members who interacted outside of the club. During the course of the study, the club split into two due to some disagreements between two of the club leaders. Based on his analysis of the social network, Zachary was able to predict which of the two new clubs each member would wind up in with near complete accuracy. So for this, I'm going to touch on it briefly, but I'm really glossing over it here. I generated the relationships or the edges between the network nodes using a Python library called NetworkX. And then I used an Excel extension called NodeXL to assign the XY coordinates for the nodes. After that, I unpivoted the data so that Tableau knows how to draw the path between the nodes. Tableau thinks in terms of tables, so to get this kind of information in table form, we need to duplicate the edge information so that it can be associated with both a beginning position and an end position, and these are labeled A and B respectively. It's also necessary to make sure that each relationship has an ID number. This will allow us to disaggregate our edge data appropriately. So let's switch to our workbook. Okay. So I'm going to...
What's going on? Try it again.
Okay. All right, I'm going to begin. Okay. I'm going to begin by making sure that we've got the Karate Network data set selected. And then I'm going to, this is pretty straightforward, I'm going to place X on columns. And I'm going to place Y on rows. So when we do this, the aggregation defaults to sum. I'm going to change the aggregation to average. Okay.
Why do you do that?
So the X and Y coordinates represent the position of each person in the network diagram. So as I said, we have 78 connections and 34 people. So there are people in the data set who will have more than one connection. So, but since we want to be plotting those coordinates and not summing them, we change the aggregation to average. We could have also used min or max, but using sum here doesn't make sense. All right, so now what I'm going to do, two hands here.
All right.
Okay, so here, this is fun. Here I'm going to command click drag the Y. Oh, I am going to command, not control, but on Windows it would be control. I'm going to command click drag the Y pill. And now what we get is we get two panes in our viz. It keeps falling down.
Sorry.
keeps
I'm
gravitating.
looking at your viz.
Okay, because it's awesome. Okay, so we get 2 panes in the viz, but I want to draw your attention to the marks card here. And I'm gonna undo what I just did. Take a look at the marks card. I undo what I just did. We see the marks card, you know, as we're familiar with it out of the gate, right? But now, when I duplicate and have 2 panes, now we have 3 cards here. We have 3 panels on the marks card. The first one, all, if you place things on there, it's gonna apply to the entire viz. And then these other ones will correspond to each of the panes in the viz. So first, I'm gonna work with the bottom panel, and I'm gonna visualize the nodes of the network. So I'm gonna go to the panel which corresponds to this bottom pane. And for our mark type, I'm gonna select circle. And our nodes here are represented by our vertices, which I am going to drag on, I'm gonna drag onto label. And so now we have our nodes. Each person in the karate club network is associated with one of these nodes. Now that we have our nodes, we need to take care of our edges.
Why don't you make it a little bit bigger?
Oh, yes, and like I did before, I'm gonna go up here to the View Fit Affordance, and I'm going to select Entire View. Now, I'm going to go to the Marks Card panel, which corresponds to the top pane, and I'm going to change the mark type from automatic to line. And once again, I'm going to draw your attention to what's going on in the marks card there. If I undo that, you'll see that we had a drop target for shape. But once I change the mark type to line, we now have a drop target for path. That's going to allow us to draw a path for the edges, where we will provide Tableau explicitly with the path it needs to draw. Now, if time were on the level of detail, we would have an obvious, sensible, predetermined order for our points. But with the network nodes, we need to explicitly provide that path information. All right, so the path order is the AB field that we created when we unpivoted the data. But before we use the AB data, we're going to put ID number onto the level of detail and see what happens. Our ID dimension provides an ID number, one identifier for each of those 78 connections between people that I mentioned. It's just an integer identifier. So each connection has one edge and two nodes. One person is the A node, one person is the B node. When we pull ID number onto the level of detail without giving it the AB information, we don't get an edge graph, we get a line graph. Okay, this is because Tableau is interpolating between the points, which is a completely reasonable thing to do, given that we have not provided the AB information yet. So we're going to take that AB data, and we're going to drop that onto the path drop target, and now we have the edges in our network diagram. And now I'm going to take care of a couple of formatting things. I want to contrast the color of the edges and the nodes. So I'm going to go here and pick a contrasting color. I'm also going to edit the axes so that we don't have unnecessary white space in there. So I'm going to select a fixed axis. I'm going to start that axis a little bit below where our marks start. And I'm going to end it at the same place for both of these panes. So I'm going to do that now. Here, same thing, edit axis, fixed. Same as the other pane. All right, and now I'm going to do the same thing that Kenneth did earlier. I'm going to hide the axes because they're not really giving us relevant information here. What's important here is the relationship between the nodes, not the coordinates of the nodes themselves. So I'm going to go up here. I'm going to show you another way to skin the proverbial cat. And I'm going to go up to the pill on the rows shelf, and I'm going to deselect show header. And I'm going to do the same thing for our x-axis. Okay, so now that we have both our nodes and our edges represented, it's time to overlay these into the same panel. So I'm going to do that by coming to the second pill here on the rows shelf, and I'm going to select dual axis. And so now we have a coherent network diagram. Okay, so to recap the concepts that we introduced here. We discussed how we took a network data source and we briefly discussed how we took a network data source and built node and edge tables before importing the data into Tableau. We talked you through how having the node and edge tables allow us to tell Tableau how to draw the path in the network diagram. We showed you how Tableau lets you work with distinct levels of detail by providing multiple panels on the marks card. And we took 2 panes in the viz, and we overlaid them using the dual axis feature.
Okay, so what did we cover today? We showed you 4 vizzes that aren't in ShowMe and broke them down into their component parts.
We showed you a slope graph where we used rows, columns, a calculation, and a color encoding.
We showed you a waterfall chart where we used, again, rows, columns, a calculation, and, the Gantt mark type, size, and a quick table calc, the running total.
And we showed you a tile grid map where we additionally, we used a new mark type, a color encoding, and an outside data source to provide a scaffolding or structure.
In this screenshot, you can see what the labels are supposed to look like. And finally, we showed you a network diagram using multiple marks cards, a dual axis, and the path drop target. Here we have some related sessions. So imagine this talk, but with more advanced viz types, if you're interested in continuing on this path. We can, instead of you having to write all this down, I can certainly show this to you afterwards. And finally, we'll open up to...
We would love it if you would open your TC app and fill out the survey about this talk, and that's how we learn what you want to see at TC 18.
So the more feedback you give, the better feedback you give, the better time you will have next time because it'll be more tailored to what you want and need.
Thanks again for joining us, and we're happy to take questions now.
Go ahead. Oh yeah, you bet. I'll leave that up.
Yeah.
I'm pretty sure I didn't answer this. So if you want to do a slope graph with multiple or more than 2 axes, the calculation is basically the same, right? Except you have to calculate the mean all the different years.
With more time points, you mean?
Right.
So the question is, if you want to do a slope graph, but with multiple time...
Say 4 years.
Sure. And the rest of the question was?
Well, I'm just assuming all the calculations would be the same, except would you have to do a separate calculation between year 1 and year 2?
Oh, so, right. So, and this is specifically you're asking to have that color encoding per year?
Right.
Yeah, that's actually fairly complicated, so I'd be totally happy to talk to you about it
I think
after
I know
this talk.
a simple way to do it. Remember when she was picking out first and last?
No.
If you want the difference between the first year and the last year to indicate whether it's positive or negative, you could still do that.
No.
One each year.
Oh, okay, all right.
Right. Yeah, to do it, no, that's a really great question, and it's actually pretty interesting, and I'd be happy to take a look at that with you afterwards, but it's, yeah, it's pretty tricky.
Go ahead.
On the waterfall chart, it is either up or down for the day. What if you had something like sales and loss of customers, 2 things, one up, one down, you want to show both?
Good question.
Gain of 17 customers, loss of 3?
Yeah, so that would just require an extra calculation to determine that.
The question I'd have, though, is that if the waterfall chart's based on a running total, what is your running total going to be of? Like you need it to be of one of those measures? Sorry?
Of the net.
Of the, oh, I see what you're saying. Okay.
So they have one bar with the net would be here,
Uh-huh.
and then how many they took to get up and how many down, and then the net.
Wait, this would be similar to the Seahawks viz, correct?
I'm not sure if you did two different charts with the same running total, and on one of them had the size for the up, and one of them had the size for the down, and then you did the dual axis thing. That might do it. You might be able to overlay them that way. But that's a good question. I'm going to play with that and try to figure that out. Go ahead.
For the tile grid, how did you calculate the coordinates? Can you show this file?
Let me show you. So this is literally what I did. I took a piece of graph paper and I overlaid it over a map, and I made estimates. I mean, these are approximations of where Montana is or where Florida is, that sort of thing.
Right. And if you look around on the web, you'll see that some people will do tile grid maps slightly differently, right? Like, should Wisconsin be above Illinois? Should, some of these are, it could go either way, right? So if you look on the web, you'll see examples, and they're not all tile grid maps of the United States look precisely like this. But the idea is that you get this general sense of the geographic location.
So just a quick question, like, if you import image in Tableau, you can do also coordinates on the image with Tableau too.
Oh, absolutely, yeah.
Yes.
So that's good. Okay.
Yeah, so the question was that you can, or statement was that you can import an image into Tableau and also have coordinates on top of the image.
Mm-hmm. I think you had a question in the black? Oh, yeah.
Okay, and then over here?
I have the home address and then the destination address, like for a travel agency, put it that way. And I have 17 years of data, and we've got things that impacted, like the hurricanes in the Great Barrier Reef last year, the hurricanes and the islands right now. What is the best options or your recommendations to how I visualize long-term trends of travel, like globally?
Well, so do you mean that you would want? So let me actually let's start passing the microphone.
Oh, yeah.
You said 17 years of travel data.
17 years of travel data with.
Here you go.
Hi, everyone. 17 years of travel data with the home location and the destination location. And I want to see like the long-term trends of where they're coming from, where they're going to, and then the second point is of the destination, where they're coming from, but then the impact of things like the hurricane impacts here in the Americas, and the islands, and then last year the Great Barrier Reef was really impacted from a travel perspective. So trying to figure out through the conference how to best visualize that and to analyze the travel trends.
That's a great question. Like nothing jumps to mind. But if we sit down and look at the data, I think that might be an easier way than to figure that out than describing it. But a doctor appointment might be a great way for you to, yeah, if there's openings. I mean, there should be openings. And when someone's actually sitting there looking at your data, it might be easier for them to figure out this is the best way to represent it.
And you can explore those.
Yeah, I mean, I've got point to point, I've got everything you could need. I don't know how to get that much data digestible.
Sounds like a job for Viz and Tooltips. I said, sounds like a job for Viz and Tooltips.
And you'll have a beta out for that really soon. Yeah.
I think the beta's out as of this morning.
I think you're right. Okay. That's actually our team that worked on that, so we're a
Well,
little proud
our
of it.
larger team,
Yeah.
not our smaller.
When's that expected to launch?
I'm not sure.
Yeah,
Yeah.
I wouldn't try to, I don't think you want us to answer that.
Yeah. The development team is done with it. Modulo any bugs that you find, but as to when it actually goes out officially.
What?
Yeah.
Back there?
Yeah, for the waterfall charts, you should use the sum function. But if you want to... So for the waterfall charts, you use the sum function.
Mm-hmm.
But if you want to track performance over time, like we'll typically we use average. I wondered if you can do the same thing with the waterfalls with average instead, or?
So I'm not certain, it's easy enough to sort of
So,
play around with that,
it-
but
yeah.
you do need to have an aggregation. So,
I really, in that chart, the sum was there just to trick Tableau into using aggregation. It wasn't because we were summing something up, because there's only one data point in each case. So I think average would work fine, but we can go try it out if you want. We'll go try it out right now.
So to kind of build off that, it's not really a waterfall chart, but like, could you build towards a running average? Like the average after 1 point would be the data point. The average after 2 points would be the average of the two. And then as you go on, it would like kind of aggregate towards the middle.
I think you could. You notice that I used running total for my base calculation, but running average is another one of the table calculations, and you could try that and see what it looks like. That could totally work. Yeah. In fact, yeah, I'm thinking that like you would have the up and down at each stage, each hand or each game or whatever it is, and that it would sort of slowly converge on what the long-term running average would be. Yeah. Or I'm not sure if Tableau lets you look back, like let's say average the last 5 at each point or something like that, but it should, yeah.
So that's do something like that, and I never made the connection between that and like a waterfall chart. They're kind of the same.
Yeah, so a waterfall chart is just a size mark overlaid on top of a table calculation. Yeah. And there's many table calculations. So.
do we have a...
Oh, sorry. Oh, you got it. All right.
I was just wondering, I don't think your waterfall had a solid bar on the right. Do you just have to put in a grand total at the end? Or?
Oh, you do, and I think we've done that in previous times we've demonstrated this, and we didn't do it this time. Let's see. So, waterfall, if I did this and did a grand total, bingo, there you go. Rename it, you could format it. Yeah, I'm not sure if you can, oh yeah, you can call it, foo. You can call it whatever you want. Any other questions?
Any other questions?
All right, well, thanks everyone.
Yeah,
Appreciate you
thanks for
coming out.
coming.